Cleaning and corrosion. Cleaning. Some non-approved commercial cleaning compounds can cause a chemical reaction with metals of the aircraft structure, which releases hydrogen gas that can be absorbed into the metal and causes hydrogen embrittlement, which will weaken the metal and cause cracking and failure. So we do not use non-approved commercial cleaning compounds because it causes hydrogen embrittlement of our metallic structures. Magnesium parts are cleaned by washing them with a commercial solvent, such as naphtha or Stoddard solvent, then soaking them in a decarbonizer that has been proven safe for magnesium. Any hard deposits that are not removed by this treatment can be removed with a scraper or a grit blast. And mechanical removal of corrosion is limited to the use of stiff hog bristle brushes and similar non-metallic cleaning tools. Reason being is magnesium is a really soft metal and it is very prone to corrosion. So if you use like an aluminum or steel brush, you can scratch it. You can leave metal particles behind, which would cause dissimilar metal corrosion. So be very careful when cleaning your magnesium and use soft, non-metallic cleaning tools. Aliphatic naphtha is used for removing fingerprints, dust, oily deposits that have settled onto a surface in order to prepare the surface for painting. Aromatic naphtha is a coal tar derivative that's toxic and it attacks our acrylics and rubber products, so it is not suitable for use on aircraft because we have acrylic plastics and rubber obviously with our tires and whatnot. So Al is our friend, aliphatic naphtha. Aero, no, you do not use aero. Cleaning. Battery acid neutralization for lead acid batteries, we use baking soda and water. For our NiCads, we will use boric acid or vinegar. Flammable agents, we will use a cotton cloth or natural bristle brushes. This prevents the static electricity buildup created when using synthetic fibers. So use natural cotton or natural bristle brushes to clean with flammable agents. Emulsion agents use atomizing spray equipment, scrubbed with natural bristle brushes, and washed from surfaces. So remember, your emulsion agents will be atomizing spray. Fade surfaces are the parts of the structure that are covered in a lap joint, so they overlap. They need to be protected so that corrosive materials do not seep between the sheets, such as sheet metal, and the lap joints, causing hard to detect corrosion. Our anodized surfaces should never be cleaned with anything that could scratch through the anodizing and expose the untreated metal alloy underneath, or that could contaminate the surface. For this reason, only aluminum wool and fiber bristle brushes are suitable for cleaning an anodized surface. Any corrosion on the surface of a highly stressed steel part is potentially dangerous, and all of the corrosion products need to be removed. The removal can be done with a mild abrasive paper, such as rough or fine grit aluminum oxide sandpaper, or fine buffing compounds on cloth buffing wheels. Cleaning transparent plastic windshields, you want to flush it with a clean stream of fresh water to remove all of the sand and grit from the surface so it doesn't scratch. Then you can use your soapy water to clean and then rinse with fresh water again. Cleaning oil or grease from a tire, remove all the excess material by wiping it with a dry cloth to get as much off as possible. Then wash the tire with a solution of mild soap and warm water to get the rest off. Then rinse the tire with fresh water to make sure that all of the residual is off, and dry it with compressed air. Protective surfaces An anodized coating is an electrolytically deposited film of oxide that covers the surface of the metal and keeps air and moisture away from it. Damaged anodized coatings can be repaired by treating the damaged area with a chemical conversion coating such as iodine. Iodine can be applied to a surface after all traces of corrosion have been removed. The surface should be chemically cleaned until it supports an unbroken water film. Any break in the film of rinse water shows that there's some wax, grease, or oil on the surface, and further cleaning must be done. Iodine etches the surface, providing a microscopically rough surface, and forms an oxide film on the surface to increase the corrosion resistance. Iodine is a non-electrolytic corrosion protection or conversion coating. So once again, iodine is our friend, so we can iodine out in the field. And no dyes, no, we do not do that, the manufacturer does. The inside of structural steel tubing on an aircraft is protected from rust and corrosion by drilling small holes in the end of each section of the tube and pumping a little bit of warm linseed oil through the hole. After the inside is thoroughly coated in the linseed oil, the excess oil is drained out, and the hole will be sealed with a drive screw or welding it shut. Corrosion is a natural phenomenon which attacks a metal by chemical or electrochemical action and converts it into a metallic compound, such as an oxide, hydroxide, or a sulfate. Corrosion occurs because of the tendency for metal to try to return to its natural state. There are 4 conditions that must exist before corrosion can occur. The presence of metal that will corrode, which is the anode. The presence of a dissimilar conductive material, the cathode, which has less tendency to corrode. The presence of a conductive liquid called the electrolyte. And electrical contact between the anode and the cathode. A passive oxide film could be used as a corrosion preventative. Like if you alclad your heat-treated aluminum alloy cores, and you have this pure covering of aluminum over the top, that pure coating of aluminum will try to return to its natural state. It gets a little, white and cloudy, and that provides a passive oxide film on the outside of your metal to help try to prevent corrosion. Fretting corrosion is a form of corrosion that forms between closely fitting assembled parts that have a slight amount of relative motion. So like your sheet metal joints that get riveted together, they're very close fit parts, but they will have some level of movement between each other because of expansion, contraction, vibrations, all that. So eventually you get these tiny particles built up between. When they try to come out, they usually come out of your rivets. So an example of fretting corrosion would be smoking rivets, trailing back from the rivets on your outside skin. Intergranular corrosion forms along the grain boundaries with an aluminum alloy. It does not necessarily extend all the way to the surface of the metal in its early stages. It is quite possible for intergranular corrosion to reach an advanced state before it shows up on the surface. Ultrasonic and eddy current inspection methods must be used to detect it early. So the advanced form of that intergranular corrosion is exfoliation. It's a severe form of intergranular that normally forms in extruded metals. So when metal is extruded, its grain structure is arranged in a series of layers. If an extrusion is improperly heat treated, the grains are enlarged to the extent that intergranular corrosion can form along those grain boundaries within the metal, and then severe intergranular corrosion in the extruded part causes it to delaminate. So the layers of metal will push apart. It looks like your metal is actually growing if you measure it. The surface of the metal then lifts or flakes off. Stress corrosion cracking is an intergranular cracking of the metal, which is caused by a combination of stress and corrosion. Shot peening a metal surface increases its resistance to stress corrosion cracking by creating compressive stresses on the surface. Galvanic corrosion occurs when two dissimilar metals make electrical contact in the presence of an electrolyte. The rate at which the corrosion occurs depends on the difference in the activities of the two metals. The greater the difference, the faster the corrosion. So for example, magnesium and aluminum are really good anodes that will corrode. Steel, on the other hand, is a good cathode. It doesn't like to corrode necessarily. So if you put steel with magnesium, the steel will be asking for the magnesium's electrons, and then magnesium is forced to give the steel the electrons. So that's how that corrosion starts happening. If you have a small magnesium part and a large steel part in contact, the steel will have a greater demand for those electrons, so it will make the magnesium corrode faster. If you have a large magnesium part and a tiny steel part, like a screw or bolt, then the demand for electrons is smaller, so the corrosion will happen slower. Still happens. Most of your anodic metals are soft, like magnesium and zinc. Most cathodic metals are hard, or noble metals, such as gold or stainless steel. The anodic metal is the metal that corrodes because they're giving up their electrons. So size is one thing that's going to affect corrosion. Size of your anode and cathode. You can also put sacrificial hardware like zinc to corrode first, and it actually saves your anodic metal that's mating up with the cathodic metal to have a sacrificial washer or something. You can also stop galvanic corrosion by putting something between them and insulating the metals from each other, such as a coating of paint, a rubber gasket, anything like that. When a reciprocating engine is prepared for storage, the inside of the cylinders are sprayed with a mixture of engine oil and a preservation oil, or preservative oil. The oil mixture forms a seal on the cylinder wall and across the top of the piston. If the propeller is turned once all this oil is put in there, the pistons will move, which will break the seal that it formed. So then air and moisture can reach the cylinder walls and cause them to rust, which we don't want to happen. So a lot of people will remove their propellers when it's going into storage so that it doesn't accidentally get moved and break that seal. Mercury spilled in an aircraft will require immediate action for its isolation and recovery to prevent it from causing corrosion damage and embrittlement of the aluminum structural components. It goes through a process called amalgamation, and it's a rapid and severe corrosion that destroys the structure very quickly, which is why immediate action must happen. Mercury is also very highly toxic to you and spreads easily from one surface to another.